All right, welcome back everyone. In this video we're going to go through the expected value or the mean of the sample proportion as well as the variance and standard deviation of the sample proportion. So remember that the sample proportion is a variable. We call it p hat and it just means the proportion of our sample that has a particular characteristic. So two formulas to kind of get our heads around in this section. First one's actually really easy. The first one says that the mean or expected value of p hat is equal to the population parameter. That is, the expected value of p hat just equals p. Now, the notation makes that seem confusing, but it's actually quite logical, right? Like let's just say that you knew that the whole population of Australia, let's say we knew that 10% of the population was left-handed. Well, that should mean that if we took a sample of, I don't know, 500 Australian people, just completely at random, you would expect that 10% of that sample should also be left-handed. Doesn't mean that that's definitely what's going to happen, but that would be the expected value. So the expected value of the sample proportion is just equal to the population parameter. So expected value of p hat just equals p. Nice and easy one to apply. The variance and standard deviation, a little bit more complicated. The variance of p hat is found using the rule variance of p hat equals p times 1 minus p divided by n, right, where p is the population parameter and n is the sample size. And like with all the other times we've used anything to do with variance and standard deviation, once you know the variance, the standard deviation is just the square root of the variance. So you'll notice that this standard deviation formula is exactly the same as the variance, but we've just put the square root sign around everything. Okay, as always, sometimes when you jump into some examples, these formulas start to kind of come together and make sense, so let's do that right now. Okay, in a population of 250 students, 100 have overdue homework, right? So our population is 250. A sample of 30 students is chosen from this population. Part A says, state the value of n, the sample size. So in this case, n, the size of the sample is 30 students, so n equals 30. Right, we're going to need that for our formulas a bit later on. Find the value of p, where p is the proportion of students in the population who have overdue homework. Right, so we were treating in this question the population as being a total of 250, and 100 of those people had overdue homework. So p, the population proportion, is 100 out of 250, which of course can simplify down to either 2/5 or 0.4, depending on whether we want to work with a decimal or a fraction. Okay. Part C, and this is where we get to practice these formulas. Determine the mean of the sample proportion, which is written as the expected value of p hat. Now remember that the mean of the sample proportion, so if we're going to take a sample of 30 students, the expected value for p hat is just equal to p, right? So it's equal to, in this case, 0.4. That's just applying this formula here to question C. And again, it kind of makes logical sense, right? If 40% of these 250 students have overdue homework, well, we would expect that when we take this sample, 40% of those students would also have overdue homework. May not be what happens, but that's our expected value or our mean. Okay, find the standard deviation of the sample proportion, SD of p hat. So this is where we're going to use, we've got our variance and standard deviation formula, we're going to use the standard deviation one. And we just need to carefully identify the values of n and p. So standard deviation of p hat equals, I'll just copy down the formula first, it's p times 1 minus p over n, and it's the square root of all that. So in this question, we already wrote above, n was 30 and p was 0.4. So we get 0.4 times 1 minus 0.4, and of course 1 minus 0.4 will be 0.6. All right, that's all over 30. And so, let's see, I didn't write this as a calculated question, but it probably makes more sense as one. So that would be, what, 0.24 over 30, or we can get as far as we can get without the calculator. What's that going to equal? I don't know, I did approximately equal. Equals, times top and bottom by 100 and get the square root of 24 over 3,000. What's that going to come down to? Oh, we can cancel it down a fair way. Tell you what, I'm going to be lazy and chuck this in the CAS. I think that I probably intended it to be a calculated question, but didn't write it on the sheet. So bear with me a sec. I always look like a fool when I don't check the answers before I do the video, but anyway. All right, so if we do it standard mode, we could get that down to root 5 over 25. But if we went to, say, 3 decimal places, we'd get 0.089. Right, that would be the standard deviation of the sample proportion. So standard deviation, like, remember that it measures sort of, it's an indication of spread, okay? So in the context of p hat, the standard deviation is kind of like giving us an indication of how likely our sample proportion is to change based on the particular values that we've got for that question. And when you look really carefully at the formula as well for the variance and the standard deviation, you'll notice that n is on the bottom, n is in the denominator for both of them. So what that kind of means is that the bigger the sample proportion, the bigger the size of n, the smaller the variance should be. And again, that kind of makes sense because the bigger our sample size is, the more reliable our sample proportion should be. And so that's why a larger value of n will lead us to a smaller variance and smaller standard deviation. Okay, this next one's an exam question from a few years back, so let's give this one a go. It's a pretty tricky one, but we'll give it a go. If you want to pause it and try it yourself first, that's not a bad idea. Okay, a student performs an experiment in which a computer is used to simulate drawing a random sample of size n from a large population. Okay, the proportion of the population with the characteristic of interest to the student is p. All right, so p is the population proportion, n is the sample size. So it's a really complicated way of just giving us the information that we're really used to. Let the random variable p hat represent the sample proportion observed in the experiment. If p equals 1/5, find the smallest integer value of the sample size such that the standard deviation of p hat is less than or equal to 1/100. This is a really poorly written question that is actually just getting us to use the standard deviation formula in a pretty normal sort of way. So let's just start with the formula itself. So this is saying we've got the standard deviation of p hat, and we know from the formula on the previous page, actually tell you what, those lines have come out pretty small. Let's see if I can get a scrap bit of paper to write on instead so I can spread it out a little bit more. So the standard deviation of p hat is equal to, so our formula says that that's going to be equal to the square root of p times 1 minus p over n. All right, so let's start with the formula. Let's put in what we know. So in the question, in this part A, it was saying if p equals 1/5, so we would have 1/5 on the top, 1 minus 1/5, well, that would give us 4/5. N is unknown because the question's saying find the smallest integer value of the sample size. So in other words, we don't know the value of n, so let's just leave it as n. Such that the standard deviation of p hat is less than or equal to 1/100. So we actually want to let the standard deviation equal 1/100, or be less than or equal to 1/100. So what we might do first is let's just see if we can simplify this expression we've come up with for p hat. So we've got, on top, we've got 1/5 times 4/5, so that's going to give us 4/25. And we've got to divide it by n, but I'm going to write that as times 1/n, just for the purpose of us simplifying this a little bit. Because now what we can do is we can say, well, that's just really the square root of 4 on 25 times the square root of 1 on n, and the square root of 4 on 25 is 2/5. Square root of 1 is 1, square root of n is root n, and so we can kind of get this down to 2/5 root n as a way of expressing the standard deviation, okay, of the sample proportion. Now, the question was saying that we want this, the standard deviation of the sample proportion, to be less than or equal to 100. So we can say, let's let 2/5 root n be less than or equal to 1/100. And this was actually a non-calculated question, so it gets a little bit tricky here. We're just going to kind of solve this for n. So best bet, I think, would be to cross multiply and get 200 is less than or equal to 5 root n. So that's just multiplying both sides by 100 and multiplying both sides by 5 root n. We can divide both sides by 5 and get 40 less than or equal to root n. And then if we square both sides, we should get a value for n. So we would get 40 times 40, well, 4 4s are 16. Work out the zeros, we get 1600 is less than or equal to n. Or in other words, n would be greater than or equal to 1600. So if the sample size is 1600 or bigger, then the standard deviation will be less than 1/100, or less than or equal to 1/100. So we would need n to be greater than or equal to 1600. The question said, find the smallest integer value of the sample size. Okay, so the smallest whole number that would give us a standard deviation that's less than or equal to 1/100, well, the smallest whole number would be n equals 1600. Okay, so that would be our answer to the question. It's one of those ones you've got to read it carefully. So the answer actually is 1600. We don't have to say 1600 or more because it was asking us to give the smallest integer value. So obviously I did my work on that bit of scrap paper there, but I'll just put my answer on this as well. All right, so that one's a pretty tricky question, but it's worth knowing and seeing how it works. And like with lots and lots of formulas in maths, once you know and have established a formula and have practiced using it the kind of the normal way, often trickier questions will get you to work backwards, you know? So you might have standard deviation formula, they actually give you a fixed standard deviation and you have to go back and work out P or N, just like we did in that last question. It's a really common, more challenging question that they might put towards the end of a SAC or an exam to really sort you guys out. So, you know, watch out for those ones, but don't be thrown off by them. And it's often a good idea to just, like we did in this scribbly solution here, start with a formula, put in what you know, and then go from there. I hope that's kind of helped. It's a pretty tricky section, this one, so give it a go, but as always, reach out to your teachers if you need a hand with anything. Cheers.